My name is Oren Blonder, and I am the Regional Director for EMEA and APAC in Whitewater Technologies. I will talk today briefly about who is Whitewater Technologies, what is the Smart Water Network, and where does BlueBox fit in, what is the BlueBox Intelligent Water Analytics System, what is the challenge to detect anomalous distribution system events, how does the BlueBox address these challenges, what is the basic user experience. We will then go through a quick product demonstration, and then I will shortly review some interesting dual-use benefits through examples, and we'll have some time for questions and answers. So let's begin. Okay, so shortly about Whitewater Technologies. We are a leading technology provider of smart water network monitoring and management software solutions. We are focusing in analytics, workflow management, and efficiency. What is a smart water network? We have 5 layers of the smart water network. This is from the SWAN forum, where the first layer is the physical layer of the pipes, valves, and everything around it. The layer above it is the sensing and control. The third layer is collection and communication. The fourth layer above it is the data management and display. And the fifth layer is the data fusion and analytics. The BlueBox fits on the fifth layer, and this is what we're going to talk about today. So, what are today's challenges for the average water utility? We've identified 3 main challenges. The first one is meeting the regulatory targets. The challenge is to remain within the compliance of those rules already enforced and staying ahead of proposed regulatory changes and legislation that is currently being enforced. The second challenge is knowledge loss. We've seen a research from 8 years ago, 2005, that revealed that the average age of water utility workers was 45 years old, and the typical retirement age was 56. That means that about 40% of the workforce will be retiring within 2 years. All those experienced engineers will take the knowledge with them, and the organization will face a challenge. The last challenge that we are trying to tackle is the big data. How can a utility make sense out of the many data points that are being logged on short seconds to minutes intervals to provide better decision support to employees? Adding brains to the data collection system. This is one of our main targets. This is the BlueBox, the Intelligent Water Analytics System, a product that we've developed in here at Whitewater Technologies to work slowly on the water sector. The BlueBox is a self-learning analytics software which enables real-time analysis and alerting of large quantities of continuous operational and water quality data. The challenge is discovering anomalous distribution system events in real time. And this is how we try to do it. We have integrated together unsupervised machine learning algorithm, holistic water quality outlook, advanced algorithms, and alarm rationalization. And this is how it works. Basically, we take values from several parameters on the same timestamp. If now the time is 10 a.m. in the morning in New York, for example, the pH could be 7.1, the turbidity could be 0.2, the free chlorine could be 0.3, and the conductivity can be 700 microsiemens. We then go back and compare this specific combination of values to a history of time. Here you can see a density map of just two parameters, pH and color. Obviously, I can only present here combination of two parameters due to the fact that we can see 3 dimensions, but the BlueBox have the ability to look on up to 8 different parameters for the specific monitoring station. Here you can see that even though all the history of time is within the pH regulatory threshold of 6.5 and 7.5, we can see specific locations where the water like to be in a steady state solution. Meaning, if for example, the values right now would be pH 7 and color 0.4, that would mean that we are in a new situation which usually trigger an alarm that says one of 3 things. A, you can have a change in your source of water, for example, from surface water to desalination water. B, you can have sensor malfunctioning. Or C, you can have a pollution in the water. Now, again, even though we are within the regulatory thresholds, there could be a water pollution here. The BlueBox has a very strong ability to detect those abnormalities and alert that right now you are in one of the 3 situations: water source change, sensor malfunctioning, or pollution in the water. At the same time, as you can see on the graph on the right side of the screen, the user interface shows that a specific cluster is being dropped from a density of more than 40,000 times in the past year to 0. That detects a very significant event in the water. At the same time, we add advanced statistics, but user-friendly. We have, as you will see in the product demonstration in a few minutes, event log, severity, alarm rationalization, and knowledge capture, meaning the operator, the water quality engineer, or the water utility director general can insert to a specific event, what have happened in this specific alarm. So in the future, you can go back to this event log and understand what happened. We usually integrate the BlueBox through a GIS viewer. We work with an ArcGIS version 10 or higher, and you can present, and again, as you will see in the product demonstration in a few minutes, the layer of sensors, facilities, assets, and more than that. You can see the insights provided directly on a GIS view. You can see the supporting analytics displayed in this specific view. And a very important added value is the fact that you can have enables situational awareness, where you can see an event going through one monitoring station to another. But at the end of the day, it unifies the management of information. I will now switch to the product demonstration, and I will start, there you go. I will start with the GIS view. What you see now is the city of Tiberias, where we have 7 different monitoring stations. What you see now is our QA environment. Okay, this is not the live environment, but this is very similar, where you can see right now that at site 1 we have a severe event, at site 2 we have, sorry, at site 3 we have a medium event, and at the rest of the sites everything is normal. Okay, so for example, if I want to zoom in, I can choose the location. Here we have two sites that are nearby, site 6 and site 7. I can choose the locations, zoom in, and literally see the different sensors that we have in this specific monitoring station. Another way is to go to the entities. I apologize that this is in Hebrew, but I'm going to zoom in to site 4, where I can see the different sensors that we have. For example, the flow sensor, the different pumps, the pH, etc. On the right side of the screen, you can see the current status. I just switch back to full, where you can see the different events and the different alarms that we have. And again, the idea here is that in a snapshot, the operator or the water quality engineer can see what is happening in your water network right now. You can see it in Tiberias with 7 sites. You can think of Philadelphia with more than 40 sites. Or you can think of Sydney, Australia with more than 250 different monitoring stations. Okay, so in a snapshot, you can understand what is happening. Okay, so if I want to see a specific event, I can go in and see the specific sensor. Here I can see that the pH is above regulation. Okay, it's in high. Where I can see that the regulatory thresholds that we've put in are 6 and 9. The current, the average is 7.7, and the current value is 2.9. Again, this is not the real client environment. This is just for the demonstration purposes. Okay, so people in Tiberias can still drink their water now. But you can then go into the specific graph and see what has happened in the past few hours, days, weeks, etc. Or you can choose the more interesting multi-parameter chart, where you can choose the different parameters that are interesting for you to view. For example, I want to see the pH, the turbidity, the electrical conductivity, and the free chloride at the site. Okay, so again, you can only see data just for the couple, a few hours, just for the demonstration purposes, but this is a very important tool. Now, if I want to examine a specific event and analyze what happened in the water at this specific moment, I have two very strong, powerful tools to analyze what happened. I'm now switching to the BlueBox view, okay, not on the GIS view. And you can see, again, this is another example from another place, where just in a few sentences, what we see here before we dive into the analytics. We see here the different sites names that we have. We see here shortcuts to the most common utilities that we have. And on the bottom part, we can see both on the left and on the right side a graph that shows us, or the raw data that shows us what is the current value that we have what was the minimum, what was the maximum, and where we are comparing to the average. So for each specific parameter, you can see it as a graphical, what we call the polar view, or a table with the graph. Again, since this is an offline demonstration, the current values are all 0. Okay, so if I want to dive into the events, I will hit show closed events, again, since this is something that we are doing just for the demonstration purposes. And you can see here when the event started, in which site, what is the duration of the event, how long did the event happen, what is the specific sub-model, meaning, if you remember going back a few slides, I explained that the BlueBox looks on a specific combination of values. You can see that we have more than one combination per monitoring station. So if I hit a double click on the quality sub-model, you can see that I have chlorine, conductivity, pH, and turbidity in this specific model. While if I hit double click on operational, you can see that I have level of the reservoir, chlorine, level at the exit, and turbidity. Okay, so basically we create those different sub-models. We can see the status if it's open or closed. Again, since this is an offline demonstration, everything is closed. We can see the severity of the statistical analytics that the system does automatically on a scale of 1 to 1,000. You can see the end date, and then you can see approval if it's a true alarm, meaning I want to get this type of alarms in the future, or if this is a false alarm, meaning I don't want to get these types of alarms in the future. That allows the system to be very configurable, and you can literally change the sensitivity of the BlueBox according to your needs. Okay, but the most important thing is the fact that I can add comments. Okay, if I go into a specific event, I can see that the comments was wastewater in the system, close valve 1, and again I can go in and see, I can add more comments and say contact supervisor, okay, and I can just really put all the information that I want. So again, in the future, I can, 1, go back and see what happened, and 2, and maybe more important than that, is the fact that I can, if I will have a similar event in the future, the system will automatically pop up these specific comments and say, hey, please note that on March 5th, you had this similar event, then you wrote wastewater in the system, close valve 1. Okay, so very important in terms of the knowledge retention. So going back to how I understand what happened in a specific event. So again, I have very 2 powerful tools. I'll choose just a specific event, okay, and then I can hit multi-chart. When I hit multi-chart, you can see that I have 4 different parameters, that those 4 were the one that triggered the specific combination or sub-model. And you can see, obviously I can play a bit with that and take off the pH, for example. I'll hit refresh. Okay? And what we see here is first the fact that the turbidity goes from 0.06 all the way up to 0.26, which is relatively normal. You can see that the chlorine goes from 1.3 and start climbing all the way up to 2.04. milligrams per liter, or ppm, okay, and you can see that the conductivity starts dropping from 150 to 145. Now again, when we look on each parameter alone or separately, then everything seems to be fine. But when we look on the combination of everything together, the system alerts that we have something new here. So again, you can, by the way, a lot of our clients like to have this specific screen as their online main screen, since they can see the different parameters. And again, each parameter with its own color and its own scale. Okay, you can zoom in, you can zoom out, you can go to a specific date, and you can even run offline scenarios if you want to demonstrate a specific environment. Okay, so we have what we call the multi-chart, which is more a water chemistry tool, while the second tool is the statistical one, okay, where you can see the density graph, where again the specific cluster or combination drops from 7,000, almost 7,000 times per year, okay, which takes us to 20 times per day, where the water were in this specific situation almost once an hour, to zero, to completely zero, or what is the count here, 52 times over the last year. This is a very severe event, and if I want to measure it in standard deviation of how far am I from a known or a positive or a good place, I can see here that I've gone up to more than one standard deviation away from in what I call a normal situation. Okay, so if the multi-chart is a more water chemistry point of view, the chart gives us a statistical looks at life and gives us both the standard deviation of the model movement and again the cluster frequency of the specific combination. And again, I can change from here to different combination. This is very flexible. Okay, so again, in that specific area, here we have an example of contamination penetrated to line 36B. The orders were close valve 12B, send dispatcher to sample point 36B and 36C, and contact a shift supervisor. Okay, so I know that if I'll have in the future similar event, I will know exactly that I had that on March 23rd, and this is what I had to do in order to overcome this. Okay, so I'm going back to the presentation, and I want to briefly present you some examples from real clients that we have around the world. Okay, so here we have an early event detection, where you can see on the bottom half where the SCADA system alerted at 5 p.m. when the conductivity crosses the threshold, while the BlueBox detect the abnormality at 1, 4 hours earlier than the SCADA system. Now what you see here is a 2 days time scale. So I like this example specifically because what you see here is on the following day, okay, that's on June 2010, on June 4th, while the SCADA system, detect a breach of the ORP at 3:40 p.m., the BlueBox detect the same event at 40 minutes earlier. Now the BlueBox was developed to detect mainly water quality issues, we quickly understood that we can use it as a dual use, both for operational, since we can detect operational changes in your water network through looking on the combination of operational sensors and water quality sensors. Okay, so here we have an example of a main break at a 48-inch main break that produced a significant demand in the distribution system, and we detected it through the peak of the turbidity, okay, that you can see in front of you. Now, what was nicely about this one is that we monitored several monitoring stations in this specific event, and we saw in a downstream monitoring station how the event traveled through the system. So what you see here is again the peak of the turbidity and how the event moved on to another location. Now the main issue here was the fact that it was below the surface. Okay, so if you have a main break and you see a geyser go out from the road, then that's fine. You will have probably a few tens or hundreds of people calling saying, hey, you have a break in the pipe. But the question is how can you detect main breaks as a non-revenue water below the surface? Okay, and what you see here is again through the statistical point of view, the average and max density dropped below the statistical threshold and issue an alarm. And on the bottom right, you can see that in terms of standard deviation, this specific alert picked more than 20 standard deviation from a normal place. Okay, that immediately triggered an alarm, and the operator of the BlueBox in this specific water utility immediately went on, understood what happened, and was able to trigger the relevant procedure. Okay, the next example is for the water quality ward of a turbidity spike, where you can see a very strong turbidity spike, while in the statistical point of view, you can see on the upper left side an average and max density dropped again below the threshold, resulting in alarm, while the model noise, you can see the spike here of the model noise also resulting in an alarm. By the way, we do not issue in this example two different alarms. Obviously, this is both of them, we combine several alarms into an event. Okay, here we have a system incident of a damaged service line, where you can see again the turbidity going crazy and the free chlorine. Where you can see again from the statistical point of view the initial turbidity spike on the left side, the changing of the parameters due to the loss of the pressure and the break in the service line, and then resulting turbidity when the line was put back in service. Okay, so this is a very important tool to understand that everything is back to normal and not only alerting about an event. Now again, going back to the mixing of the source of water, this is an important issue in several territories around the world, both in the US, in Europe, in China, in Japan, in Australia, and here in Israel, where we have continuously a change of the sources of the water, that issuing a lot of false alarms. You can see here an example of the chlorine and the conductivity with a very nice example of how the BlueBox detects change in your water source, with the idea that the BlueBox says, that's right, we've changed the water source, but we are still in a normal situation. The water are good. This is a, if you will, a go, no-go situation. okay? And we have more than one client that shut down completely the alerts at the SCADA system and only looks at the alerts that the BlueBox provides. We are in the scale of reducing around 90% of the false alarms. Okay, and again, going back to sensor failure and the data validation. What you see here on the left side is a drifting of the total chlorine sensor, and on the right side you can see sensor failure. Both of them are total chlorine, and we are issuing an alarm saying, hey, what you have right now is a sensor malfunction and not a problem in your water quality. So first of all, you know as the operator that right now you have a problem that you need to face, okay? You have a sensor that is drifting or malfunctioning, but in addition to that, in terms of the water quality events, this is not an event that you would count as a water quality event. In addition to that, these days, we can integrate your information coming from manual sampling from your laboratory using your LIMS, the laboratory information software. So you can see the correlation between your manual sampling and your online monitoring, and then you can very distinguishedly see if a sensor starts to drift, when you need to calibrate it, or if you have a problem in the water. Okay, so before we go to questions and answers, hopefully I have all the answers, I just want to summarize of the benefits of the BlueBox. Okay, so you gain real-time insights into the water quality behavior. It provides alerts to abnormality distribution system events, both quality and operational. We are, and this is very, very, very important, we are sensor agnostic. We can work with any type of sensor that you have, any type of SCADA system that you have, we can work with that. We give alarm rationalization, okay, we reduce false alarms. We detect patterns of non-revenue water, which is very important, and we alert to sensor maintenance and requirements. Okay, in conclusion, it's inclusion of time series data for confirmatory analysis. Thank you.